So let us start with the question, what is clustering? Clustering is the process of dividing the entire data into groups. As we know that in the growing world, data is the new oil. And with growing demand of data, we need a method to organize the data as well. Clustering is the solution. In clustering, we do not have a target to predict. We look at the data and then try to club the similar observations from different groups. And hence, this clustering is also called as unsupervised learning method. Now, K-means clustering. We know that the property of clustering states that points within a cluster should be similar to each other. So our aim here is to minimize the distance between multiple points in a cluster. K-means come to the rescue when we are talking about clustering algorithms. K-means clustering technique is an algorithm. It is an iterative algorithm that tries to minimize the distance of points within a cluster by calculating their centroid. So K-means is an iterative algorithm which continuously calculates and evaluates the centroid of a cluster and then tries to regroup the points into a new cluster. Let's see what are the steps involved in a K-means clustering algorithm. Here is the working of K-means clustering. The algorithm first of all selects k number of clusters. K can be any number ranging from 1 to infinity, depending upon the number of data points we have. Then it selects random k points on the graph, which acts as a centroid for clusters. Third, it assigns data points to the closest centroid. It uses Euclidean distance to calculate the distance between the centroid and the data point, and then assigns a point to the centroid. Now the fourth step being, it computes and places the new centroid for each cluster. And finally, it reassigns each data point to the new closest centroid. As I said, is an iterative process. If any change in the centroid occurs, then we have to go back to the step 4 and continuously evaluate the centroid again. Now here is a snapshot of what K-means clustering does for you. You can see that initially there were these multiple scattered points on the graph. What K-means did is that it grouped all the points into a cluster and finally results in 3 groups, namely these red, green, and blue groups. These groups can be anything. Maybe it can help in dog breed prediction, flower classification, or it can help you know the potential buyers for your company. It has n number of possibilities. Now let us go through the steps involved in K-means clustering one by one. Let us understand step 1. Our clustering algorithm first takes into account k number of clusters. Let us say it is 2 here in this case. Then as you can see, 2 random centroid points are selected, the blue and the red one. They are not necessarily to be from your data set. They can be any random points of your choice or from your model's choice. Third step being, it assigns each data point from our data set to the closest centroid. This helps in forming the clusters. As you can see that the 2 data points are separated and a perpendicular line, this green perpendicular line, is drawn. It is by property of geometry that any perpendicular line drawn to a line will always have the data points equidistant lying from both the points. Now again, the computation takes place in the step 4. The centroids are again shifted. So what happens here is, we know that this centroid were not actually in its original place where it should have been. So the inertia of the whole model was calculated. We'll come to what it is in the later slides, but let us understand for the time being that the inertia of the whole model is calculated, and from that we get to know that these initial points for the centroid was not correct place for them to be. So the centroid points are shifted towards the right, as you can see here. Now again, back to square one, we can see that again the centroid points have shifted. We again need to calculate the Euclidean distance of each and every point from the centroid and again divide it into 2 different categories. Because our centroid points have shifted, due to that we went back again to the step 4 and we again started the calculation of centroid and the Euclidean distance of the data points from the centroid. So this is an iterative process which goes on continuously, which is done in the backend by your system. It continuously calculates and evaluates the Euclidean distance of the data points from a centroid and keeps on shifting the centroid to maintain a stability. Now, as I said, it is the inertia which determines whether the centroid needs to be shifted or not. So what is inertia? Inertia tells us how far are the points from within a cluster. So inertia actually calculates the sum of distances of all the points within a cluster from the centroid of that cluster. You can see that inertia can be calculated using the formula which is the sum of distance of the point from the centroid. So a continuous calculation is done. The distance from the centroid and the point is continuously calculated, and it is squared, and this summation is done. This data is stored for different number of clusters, starting from cluster number 1, 2, 3, and so on. The data is stored for n number of clusters. And next step being calculating this elbow curve. So what is elbow curve? If we look here on the x-axis, we find that the number of clusters keep on varying as we go along the x-axis. And here on the y-axis, the WCSS, that is within centroid square distance, which we calculated in the last slide, keeps on getting low and low with increasing number of centroids. This is what we needed. This elbow method plots a graph of WCSS versus the number of clusters in our k-means algorithm, and this is the point which we are looking for. This point after which the graph do not start, the rate at which the graph was decreasing is not very high. So this is the elbow, as so-called elbow, and this indicates number of clusters which can be chosen is 3. So 3 number of clusters is the best fit clusters for our data set here. So let us now summarize what happened here. Basically, we can find the optimal value of k using this elbow point graph. We select the value of k on the basis of rate of decrease of WCSS. The point from where the rate of decrease is not very high, we select that point. And in this graph, that point was corresponding to the value 3, and hence 3 was selected. And now, this is the final output of our clustering. Our WCSS helped us find that the number of optimal clusters should be 3, and hence we came out with this solution of 3 clusters which are red, blue, and green. And the WCSS formula shown below, that is the summation of distance between the centroid and each individual points. Now the applications of k-means. K-means clustering has n number of applications. These are some of the many applications that I'm mentioning here. Is that image segmentation, document classification, marketing. K-means can be very helpful in terms of marketing, and identifying the crime localities. Let's go through them one by one. Image segmentation. It is the process of partitioning a digital image into multiple segments. So image segmentation uses k-means clustering. Document classification. Clustering documents in multiple categories based on tags, topics, and other contents of the document. Documents can be classified into multiple different classes using k-means clustering, and the data set that they need is tags, topics, and the content of the document. Marketing. It helps marketers discover distinct groups in their customer bases. For example, if you are a banking company and you want to lend loan to the certain customers, you can find out which customer is a potential loan lender for you. Identifying the crime localities. With the related data to crimes available in specific locality in a city, you can identify that which area of the city is most prone to crimes, and that can help police with identifying the crime locations and hotspots and stopping them. So with this, we come to an end of clustering. K-means clustering is a very helpful and important topic, and which can be easily implemented using Python algorithms. Thank you.